Good morning everyone. In the last class we have discussed the nomenclature of some of the compounds like alcohol, aldehyde and ketone. Today we are going to study the further compounds and we are starting with the carboxylic acid. So when you are talking about the carboxylic acid COOH group, how the naming will take place? The name will be according to alkene plus OH acid. Generally we say that the carboxylic acid doesn't need any number, because when you will see the priority sequence, you will find that the carboxylic group is the most prior, and as it is most prior, the numbering will start from the carboxylic acid, and the carboxylic acid survive on the position number 1, that is always a primary system, and this is the reason why there is no numbering needed under general circumstances. So what will be the name of these of the compound? If this is the compound CH3COOH, how many carbons are there? There are 2 carbons, so it is the ethane plus OH acid, that is the ethanoic acid. Simple. If this is the compound even lesser number HCOOH, then what will be the name? The compound is a single carbon system, that is a methane plus OH acid, so it is methanoic acid. If you will talk about the general nomenclature of the compound, this compound is called acetic acid, well known as vinegar. 3 to 5% of solution of the acetic acid is considered as a vinegar, and this one is called formic acid. जब आपको मधुमक्खी काटती है तो इसी मटेरियल का सेक्रेशन करती है, जिसकी वजह से जो भी पेन हमें होता है वो होता है. Then this is the methanoic or the formic acid, this is the ethanoic or the acetic acid. What will be the name of this compound? Again a 2 carbon system, ethane 1,2-dioic acid. This is ethane 1,2-dioic acid. On the position number 1 and position number 2 there are 2 carboxylic group, so that is called the ethane 1,2-dioic acid. The compound is well known as oxalic acid. Now what's about the name of these 2 compounds? The first compound, the group is the function group COH, so यही मेन चेन होगा, ये हो जाएगा आपका ब्रांच. और जब बेंजीन ब्रांच में रहता है, मैं आपको पहले भी बता चुका हूँ कि जब बेंजीन ब्रांच में रहता है तो हम कहते हैं फेनाइल. सो दिस इज द फेनाइल, सो आई एम राइटिंग फेनाइल, एंड दिस वन इज 1 carbon carboxylic acid, that is the methanoic acid. The compound is well known as benzoic acid. Then this is the phenyl methanoic acid or benzoic acid. The common name of the compound is benzoic acid. Now see this one, a problem. One chain or the ring is here, next one is here, and this one, the third one. Which one will be the main chain? Whether this one or this one? Surely this one is not going to be main chain, क्योंकि ये दो जो हैं ये फंक्शन को कैरी कर रहे हैं. लेकिन इन दोनों में से कौन सा रखें, ये प्रॉब्लम है. और अगर इन दोनों को फंक्शन ग्रुप मान के इसे मेन चेन मान लें तो इनके कार्बन काउंट्स में नहीं आ रहे. अब ऐसी कंडीशन में इस पूरे ग्रुप को यानी COOH ग्रुप को हम कार्बोक्सिलिक एसिड बोल देते हैं. Then this is the carboxylic acid. Now what will be the name? This is the main chain now, that means benzene, and on position number 1 and 2 there are 2 carboxylic acid, so 1,2-dicarboxylic acid. So this is the benzene 1,2-dicarboxylic acid, well known as phenyl acid. So this is the benzene 1,2-dicarboxylic acid or phthalic acid. Now we are going to see the next functional group, that is the amine. When you will see the amine, what are the amine? The compounds containing functional group NH2 are considered as amine. Then what will be the name of the compound? It will be alkane plus position plus amine. That is the alkane amine. So if this is the compound CH3, CH2, CH2, NH2, then what will be the name? The compound is a 3-carbon system, that is a propane plus amine, that is the propanamine. As the functional group is on position number 1, so there is no need of numbering the position. So this compound having 3 carbon is propanamine. If this is the compound CH3, CH2, CH, CH3, CH2, CH2 and NH2, then what will be the compound? We can start the numbering from this position 1, 2, 3, 4, 5, and on the position number 3 there is a methyl group CH3. So it will be 3 methyl. Repeat set. इसे सबसे पहले लिखना होगा. Now main chain. How many carbons are there in the main chain? 5. So it is pentane. And now the functional group, that is amine. So it is 3-methyl pentanamine. If this is the compound, that is the CH3NHCH3, you can see the attachment is there, the branch is there, but when you will see where is the branch, that is not on the carbon, that is on the nitrogen. So how will you position where the methyl group is attached? On number 1, 2, 3, 4. Actually it is not on the carbon chain, so we cannot number them, because numbering is only for the carbon chain. नंबर तो हम सिर्फ कार्बन चेन को देते हैं. ये मेथिल ग्रुप अगर इसका अटैचमेंट मान लें तो ये मेथिल ग्रुप तो नाइट्रोजन पे लगा है, तो हम इसकी पोजीशन को भी नाइट्रोजन के सिंबल से ही रिप्रेजेंट करते हैं. सो व्हाट विल बी द नेम? इट इज मेथिल ऑन द नाइट्रोजन, सो N methyl. Now methanamine. I think it's clear to all of you. Now we are going to see the next functional group, that is the amide. What are the amides? When NH2 group is attached on the carbonyl system, it is called the amide. So amide are the CONH2 group. How the naming will take place? It is the alkane plus amide, that is the alkanamide. So when you will see the compound, this is the CH3CO and H2. How many carbons are there? There are 2 carbons, 1, 2. So it is ethane plus amide, that is the ethanamide. For this compound, number of carbon 1, 2, 3, that is the propane and amide, that is propanamide. There are some other functional groups are also available in your syllabus in the organic chemistry, but we are just seeing these of the functional groups. Whenever it will be necessary, we will see the naming of other compounds. Next topic is isomerism. What are the isomerism? When we talk about the isomerism, we say when same molecular formula survive in more than a single form, then it is called the isomerism. So how many type of the isomerisms are there? When you will see the type of isomerism, the isomerism is subdivided into 2 different type of isomerism, that the stereoisomerism and the structural isomerism. The stereoisomerism itself is divided into 2 clear classes, that is the optical isomerism and geometrical isomerism. Then what are the optical isomerism? Optical isomerism are those of the compounds which are capable to rotate the plane polarized light in any specific direction, either in the clockwise or in the anti-clockwise direction. If they are rotating the light in the clockwise direction, they are called the dextro compound, and if they are rotating the light in the anti-clockwise direction, they are called the levo compound. But this optical isomerism is not in your syllabus. Now we are moving towards the geometrical isomerism. In the geometrical isomerism, only one isomerism is there, that the cis-trans isomerism. The structural isomerism also have 4 classes. The first one is the chain isomerism. Second one is the functional group isomerism, where the functional group is chain. The next one position isomerism, and the last one is the metamerism. So we are going to start with the geometrical isomerism, that is the cis-trans isomerism. Before starting the cis-trans isomerism, you must know that only the alkenes are capable to show the cis-trans isomerism. Why? We will discuss later. Here we are going to take the example of the butene. In this compound, you can see the first compound. This is the doubly bonded carbons. Along with that, these are the identical groups, methyl and again methyl, and in the next one hydrogen and again hydrogen. When the identical groups are on the same side, then that is called the cis, or you can call, when the identical groups are on the adjacent position, they are called the cis products. But if the identical group, here methyl and methyl, hydrogen and hydrogen, when the identical groups are opposite to each other, they are called the trans. अगर हम यहाँ पे बात करें, जब एक जैसे ग्रुप, आइडेंटिकल ग्रुप सेम साइड में होते हैं, तो हम इन्हें बोलते हैं सिस कंपाउंड्स, और जब वो अपोजिट होते हैं तो उन्हें बोलते हैं ट्रांस. द क्वेश्चन इज आस्क्ड दैट व्हिच वन हैव द हायर बॉइलिंग एंड मेल्टिंग पॉइंट, whether it is cis or trans. Surely the trans have higher boiling and melting point because the identical groups are away from each other. They generate greater steric hindrance. They behave as a greater size of the molecule, and this is the reason why they have higher boiling and melting point. So it is the trans which have the higher boiling and melting point. Now we are trying to study that why the cis and trans isomerism is only available in the case of alkenes. If it is alkene, it will be just like a single bond, just like this chart. अब हम इसे अगर एक यूं ऐसे पकड़ें, इसे जब चाहे यूं ऐसे रोटेट कर सकते हैं, और जब रोटेट हो जाएंगे तो अगर हम इन दो उंगलियों से ऐसे मान के चलें कि ये जो हैं फंक्शनल ग्रुप, जब ये रोटेट हो जाएंगे तो क्या होगा, इनकी पोजीशन चेंज हो जाएगी. और अगर पोजीशन चेंज हो गई तो सिस कंपाउंड ट्रांस और ट्रांस कंपाउंड सिस की तरह बिहेव करने लगेगा. बट इफ दिस इज द सेकंड डबल बॉन्ड, हम दो चौक से बताने की कोशिश कर रहे हैं, और अगर इस तरह से पकड़ा हुआ है दो उंगलियों के बीच में, अब ऐसे है तो यहाँ पे ये घूम पाएगा, whether the rotation is possible? Surely the rotation is not possible. ऐसा सिर्फ तभी हो सकता है जब हम चाक को तोड़ के घुमाते हैं. Similarly, if there are double bond, one bond is sigma, next bond is pi, then the rotation of the molecule is not possible. That means the cis will remain cis, trans will remain trans. And this is the reason only alkenes can show the cis-trans isomerism. What about the alkyne? When you will talk about the alkyne, carbon have tetravalency, 4 बॉन्ड से ज्यादा वो बनाने की कैपेसिटी में नहीं है. 3 तो ट्रिपल बॉन्ड बनाने में यूज हो गया, बचा कितना, सिर्फ 1. और जब एक ही स्पीशीज है तो उसे सिस और ट्रांस की कैटेगरी में कैसे रखेंगे, वो तो अपनी पोजीशन पर रहेगा, लीनियर स्ट्रक्चर में रहेगा, अपनी पोजीशन पर रहेगा. सो यू आर नॉट कैपेबल टू एक्सप्लेन सिस और ट्रांस इन द केस ऑफ द alkynes. So the cis-trans isomerism is only available in the case of the alkene. Other compounds are not capable to give the cis-trans isomerism, and in these of the cis and trans, the trans one is more stable. Now we are going to discuss the structural isomerism, and we are going to start with the chain isomerism. As you have already studied in the class 10th standard, so we are not going to discuss in detail. So here we are going to see the chain isomerism. What is the chain isomerism first? In the chain isomerism, the same molecular formula survive in different structure of the chain. That may be linear chain, branch chain, or the differently branch chain. That is called the chain isomerism. So here you can say the molecule have same elements, same molecular formula but different molecular structure. They are called the chain isomers. Now, in this chain isomer, this is the compound what we have taken, that is the pentane, N-pentane or the normal pentane. What we can do? We can remove one of the alkyl group from the position number 1 and can put on any of the other position. यहाँ से एक methyl group हम निकाल रहे हैं, किसी दूसरे पोजीशन पे लगाने की कोशिश कर रहे हैं. So this is the compound CH3CH2. ये पोजीशन नंबर 1 है, यहाँ लगा नहीं रहे क्योंकि यहाँ पे ऑलरेडी लगा हुआ है, तो पोजीशन नंबर 2 पे लगा देते हैं. जहाँ भी अटैच होगा एक हाइड्रोजन को डिस्प्लेस करेगा, यानी एक हाइड्रोजन उस पोजीशन से कम हो जाएगा, तो ये लग गया आपका CH3. और जहाँ से डिस्प्लेस होगा उसे हाइड्रोजन डिस्प्लेस करेगा, तो वहाँ पे एक हाइड्रोजन बढ़ जाएगा, तो ये हो गया आपका CH3. So the first one is the N-pentane and the next one is the 2-methyl butane. So this is the 2-methyl butane. Now whether we can change the position of the methyl group, we can change the position from here to the next one, position number 2 to 3. But actually not, this is the third position. When it will be on this position, the numbering will start from here 1, 2. Again that will be on the position number 2. So it's not the proper compound. So हम क्या करें, इधर से हम हटाएंगे तो फिर से पोजीशन नंबर 1 पे आ जाएगा, फिर से वही कंपाउंड बन जाएगा. यहाँ से हम इस मिथिल ग्रुप को रिमूव कर देते हैं और यहाँ से रिमूव करके यहाँ कहीं पे लगा देते हैं पोजीशन नंबर 1 को छोड़ के. सो दिस इज द कंपाउंड CH3C. एक CH3 ऑलरेडी था और एक और लगेगा तो सिस्टम का हाइड्रोजन जो है वो हट जाएगा. Now CH. What will be the name of the compound? 2,2-dimethyl propane. So you can see in all of these of the cases the molecular formula is C5H12. You can see C1, 2, 3, 4, 5 carbons, 3 to 5, 5 to 7, 7 to 9 and 3, 12 hydrogen, and same in all the cases. So the molecular formula is same, the functional group is same, that means the hydrocarbon, but the shape of the chain is different, and this is called the chain isomerism. The same thing you have already studied in your lower classes, that is the class 10th standard. So we are not going to discuss in detail. The isomerism in which the molecular formula remains same but the functional group changes, that is called the functional group isomerism. So here it is the functional group isomerism. Propanol we have already taken. What is the molecular formula? The molecular formula is C3H6O, and what is the functional group? It is the aldehyde group. Then this is the first compound. What will be its isomer? If we are writing this compound CH3COCH3, you can see the molecular formula is same, that is the C3H6O. But what about the functional group? This time it is ketone. So the aldehyde group turns in the form of the ketone, and this is called the functional group isomerism. Some general isomers, whatever we are using, they are the, for aldehyde it's ketone, and for the ketone surely it will be aldehyde. For the ether it will be the alcohol. For carboxylic acid it is al yani aldehyde alcohol combination or the ketone alcohol combination. Ester, for the ether it will be alcohol, etc. So these are some of the general functional group isomers. We are going to see the next, that the position isomer. What are the position isomer? Position isomers have the condition that their functional group, the position of the functional group get changed. अब यहाँ पे देखिए, where is the functional group? On the position number 2. तो ये हो गया आपका ब्यूटेन 2-ऑल. सिर्फ इस फंक्शनल ग्रुप की पोजीशन को चेंज कर दें, then that will be the functional group isomerism. तो अगर इसे यहाँ से यहाँ ले आए, क्या होगा? It will be remain on the position number 2. तो यहाँ पे तो हम लाएंगे नहीं, इसे यहाँ से यहाँ ले जाते हैं, और जब यहाँ ले जाएंगे तो क्या हो जाएगा? ये बन जाएगा आपका CH3 CH2 CH2OH, that is the butane 1-ऑल. are the position isomer. This one is on the position number 1 and this one is on the position number 2, and this is the only difference in between these two. Both are the same functional groups, only the position of the functional group is different, same molecular formula, everything is same. The next one is the metamerism. What is the metamerism? The metamerism is the case when a heterocarbon is working as a linking system or the bridging atom. That means you can see one alkyl group is attached with the next alkyl group with the help of the oxygen, which is considered as a heteroatom. All those of the atoms which are not a carbon or hydrogen are considered as a heteroatom. So here the oxygen is the heteroatom and they are attached with the heteroatom, bridging atom. In these of the cases, in the case of the metamerism, only the position of this heteroatom changes. Where is the position of this heteroatom at this time? On the position 2. Only when you will change the position of this one, you will get the metamer. That means the compound CH3, CH2, CH2, O, CH3. That means the linking atom is on the position number 1 in this case. So it is on the position number 2 in the previous case and on the position number 1 in the next case. And this type of isomerism is called metamerism. So these are the metamers. The first one is ethoxyethane and second one is methoxypropane. So it's enough in this video. We will discuss the next topic, that is the movement of electron, which is very important topic in the next video. Till then, bye. Have a nice day.